In this exercise, we're going to be solving two-step equations with algebra tiles. These are algebra tiles right here. The rectangles, they're the x's. This is negative x, positive x. The squares are the units. This is positive 1 and this is negative 1. So we're going to be using this to represent expressions and to solve them. The first problem says 2x plus 2 equals 4. So I'm going to represent that expression with this. So 2x, this is 2x. And then it says plus 2. And they tell us that that equals 4. So that equals 4. So since I'm interested in knowing the value of one of these, the first thing that I'm going to do is I'm going to take away 2 from here. But these two were equal, so I have to take 2 from here. So now in this model I know that x equals 1. You can see right there, x equals 1. X equals 1. Before you separate them, you say that 2x equals 2. So x equals 1. So we come back over here and check. 2 times 1, 2, plus 2 equals 4. We solved it correctly. Problem number 2 says 3x plus 5, 1x, 2x's, 3x's, plus 5, this is 3x plus 5, equals negative 7. So that's equivalent to this. (3x plus 5 equals negative 7. Again, I would want to take this out of here so that I can leave the x's by themselves and go in the direction of knowing what x is, but I cannot take this 5 from here because then I would have to take 5 from here and there are no positive ones here. So because I cannot take this 5 from here because there aren't any over here, what I'm going to do is I'm going to add 5 negative ones to this side. But if I do that on that side, I have to do it on this side too. So I'm going to add 5 negative ones here. And now I can do the essential step of this model, which is that a positive and a negative cancel each other. So these two turn into 0, this turn into 0, 2, these two turn into 0, zeros. These are zeros. Now I know that 3x equals 12. I'm going to organize them in such a way. I'm going to share this 12 among these x's equally. And from sharing them equally, I can see that the answer is x equals 4 negative. X equals negative 4. I'm going to test my answer over here. 3 times negative 4 is negative 12. Negative 12 plus 5 is negative 7. That is correct. Now I'm going to do problem number 12. It says 6 minus 5x plus 2x equals negative 3. So we have 6 first. 3, 6. Then we have minus 5x, that's plus negative 5x, plus negative 5x. Plus 2x, 1x, 2x, equals negative 3. So all this is equivalent to this, negative 3. From the previous exercise, we know that positive and negatives of the same cancel each other. Negative x plus x is 0. Negative x plus x is 0. So these two cancel each other. Now I'm interested in leaving these by themselves. So I'm going to take away these 6 x's, 6 ones, but I can't do that because then I would have to take them from over here. So what I'm going to do is I'm going to add 6 negatives to this side so that I can cancel those 6. But if I add 6 over here, I must add 6 over here. I'm sorry, I used my 3 over here. Negative 3. So I have to add 6, 2, 4, 6. And now I can, each one of these is going to cancel one of those. So this is going to turn to 0. Now I have that 3 negative x's equals this. And I can readily see that each one of them is this. Negative x equals negative 3. Now, for this model, what we would say, for example, is that if we turn all of them around, then the equality is going to hold. Turning them around is the equivalent of multiplying by negative 1. So negative x times negative 1, x. Negative 1 times negative 1, 1. Negative 1 times negative 1, 1. Negative 1 times negative 1, 1. So when I multiplied all of them by negative 1, I got that x equals 3. And that is the answer to problem number 12. X equals 3. Let's test. 6 minus 15 is negative 9. Negative 9 plus 6 is negative 3. We did it correctly. Hope this helps.